then this line here is creating a cutoff point here. So we can't connect, or actually that line there is not a problem, but this line here and this line here has created a cutoff. Well, one of the things we can do is we can begin to take this tool here, for example, and I'm going to left click and I'm going to go to properties, and I'm going to say the layer here, which is currently the bottom layer, I can switch it to the top. And if I press OK here, that line, it looks gone, but that's because we've turned the top layer off. Let's turn the top layer back on again, and now we can see as we route, no problem anymore. The ground and the ground are connected to each other, and we've got now this bottom line is red, but we've got these two little green pads here. What's that about? Well, if you remember me in our last demo, and I'll show you again right now, when you select the route tool, one of the things that we feature up here are these little green circles, and we get diameter and drill sizes for these things. These are called vias. These vias are exactly what this does. And basically what it means is that your line starts on the bottom, and it goes to here, and then it hits one of these vias, and it's like a little pad. And so that connection then gets made from the bottom side of the PCB up to the top. It's like it routes it up through the board, and then now we've got a trace that goes all the way along here on the top side of the PCB and hits this pad here, and then it gets switched back to the bottom layer to create the rest of this line. Right? So all we've done is we've told the line that goes from the output here to the second pad of the level, our output pad, second point, it goes from the bottom to the top, back to the bottom, and then connects to that pad. Now, if we wanted to, we could also switch all the rest of these to the top as well, and you can see the via just moves along, switching from top to bottom. Oh, we've got a little line right there. We can switch to the bottom, to the top, sorry. It gets rid of those vias. And the via just sort of moves itself along, and the Eagle system actually just sort of automatically makes all those connections for us. In fact, I can even just go all the way back to the beginning and make that entire line now on the top of the PCB instead of on the bottom. As I press our route tool, our ground is filled in right there, all the way around. It tells me that there's nothing to do, and my layout is technically done. Now, if you're anything like me, and like I said in our last, you can tweak this forever. You can just keep playing with it, fooling around with it, trying to make this layout become smaller. In fact, if it were just me, what I would do is I would start to condense some of these parts in a little bit smaller. One of the ways that you can condense things is you can start to take these resistors and change the package of them. Let's go to package here for this. I can change the package of the CLR down to 0.2 inch pad holes. And as you can see, it sort of shrinks it down just like that. And as I rat's nest, there we go. It's moved itself down. And I can do the same. What I can do now is I can sort of swivel this part around. All I'm doing here is ripping up my trace lines because I want to move stuff around just enough so that I can figure out how to get this to come down here and become a pad right there. And I want to move this down enough. Let's see here. I can change the package of this resistor down to one space so it's fully standing. And I'm going to move this resistor down all the way to here. And I can move this capacitor down a little bit just to give me some more space. I can take this capacitor and this capacitor, and I can start to swivel them around even. Why not? I can move this package. Oh, I tried to replace that capacitor. No, I don't want. I just wanted to make this package smaller. So there we go. C1. It's now smaller. And you can just put C4 here. And well, let's move this over here like this. this is getting a little bit complicated here. But let's try some things. It's not working as well as I hoped it would. Maybe I could do this. I'm not going to escape this. What if I go like this? Package back to the 3 pad spacing. Go like this or like this? No, I want to go like this. Can't make it smaller than that. So what I can do is I can do this. Actually, that looks pretty good. Still got to figure out how to route all this stuff here, though. That shouldn't be too bad, should it? What if I went like this? And put this back up here. And like this. Can I make this work? Maybe. Let's try, and see now I've got enough room that I can move all of this top stuff down just a little bit. Move group. Just a little bit. Maybe it was 1/4 of an inch. But it was enough that it now makes my PCB smaller. Anyway, so now I begin to route out all these lines. I can do... beep, beep, beep. Keeps making honking noises at me. Now so far I've got just 2 air wires left. Tells me 2 air wires. And these are actually pretty complicated air wires. What I'm probably going to need to do is to move this ground pad over just a little bit here so that I can take this pad and go down through here. Maybe what I can do is do this. Move this over just a bit here. So it's more in the middle of that cap. As I press rat nest here, I can go up from here. Here's something I could do here. I'll take up this one, and I'm going to go straight from here up past that one there. And I'm going to create... So then we go like that, and then we go up here like this. Why not? Look at that. Okay, so now I've routed that one. If I press rat's nest, is there anything that... No, it doesn't give me any errors. But now I have to figure out how to get this one to connect to that. Can I go through there, maybe? Potentially. Actually, why don't I try this? I'm going to move this capacitor up a bit. Create a little bit more space in there. And then I'm going to take my routing tool here, and I'm going to make a top line instead this time. I'm going to come through here and connect right there to that. Now, rat's nest, nothing to do. Design rule check. Check it. No errors. You see that? Now I managed to squeeze everything in a little bit by just creatively adjusting the size of some parts, the arrangement, making things sort of fit differently. And I also adjusted the size of this part. I sort of carefully managed to route things through, change the layers of some of our lines, and overall, what I've done is I've really condensed this layout quite a bit more. I'm going to press save here, and then I'm going to switch to our menu here. I'm going to close our double-sided, pull up our single-sided, and you can see as I look at this, we've got a size of this wall here, of this line, is 10.75 or 1.075 inches. This one is 2250 or 2.25 inches. And if we go back to our single-sided layout, or double-sided layout, sorry, I'm going to do my rat's nest here, and as I press info on this, we've got a 875 or 0.875. The other one was 1.075. So we've diminished the size of the layout vertically by 0.2 inches, 1/5 of an inch smaller. When it comes to manufacturing it or putting it inside a PC, inside a pedal, that diminishing of the room means you have more room for other things, or you've diminished your cost. The overall cost for manufacturing this PCB has really come down. And that's really the benefit of going to these manufactured PCBs, is it becomes quite a bit less expensive when you diminish the size of these things. And I could probably work really hard to get this PCB even smaller. If I pull more of these parts farther this way, which creates a lot of room here, right? We can go like this. We can move this all the way over here. This can come all the way over here. There's no reason why we can't just sort of start to do that. We can may mean that we have to sort of slightly adjust the routing of some of our parts, right? But there's no reason why I can't just sort of begin the process of changing where things lie and then being able to pull all of this stuff down just even one more space. We can go down like this. Create a little bit more room vertically, right? So be able to pull this down, pull this down quite a bit, right? And then by doing so, by pulling all this stuff down, creating more room, we have diminished the cost of manufacturing this PCB quite a bit, and saved ourselves a little bit of time, a little bit of money, and everybody's happier, right? Well, that's the hope, at least. Everybody should be happier when we go to single-sided or double-sided layouts. That's the idea. Okay, so I guess I've showed you enough of my sort of my tips and tricks about how to do layouts. I'm gonna clean this thing up a bit, but that's essentially all I want to teach you today. I taught you a little bit about vias. I taught you a little bit about both the sides of the layers. My battery's running low, and so that's why I'm cutting this demo a little bit shorter. Thanks for watching. Stay tuned for future episodes in which we discuss more about how to take the layout that you've created here, both either single-sided or double-sided, and then begin to sort of translate that into something you can actually use. I'll show you how to export a single-sided layout and then adjust it so that you can use it to create an etched PCB, how you can export it so that you can actually manufacture it for yourself in your own little shop. And then I will also take you through the steps of taking a double-sided layout and how to upload that to OshPark in order to use it for manufacture through a small prototyping service, as well as how to export the Gerber files using this CAM tool here, the CAM processor. We'll show you how a little bit about that. I'll also show you some more about the design rules features right here, which is what you use for design rule check. You know, when we do our check, oh, it's not telling me there's a clearance problem right there. Well, I'll clean all these things up. But in the meantime, thank you for watching. Stay tuned for future episodes, and have a great day. Thanks a lot. Bye.